Let us look at proposition number 3 of book 8 of Euclid's Elements. The proposition says, if as many numbers as we please in continued proportion are the least of those which have the same ratio with them, then the extremes are relatively prime. So basically, if we are given 4 numbers in continued proportion, yes, which are the least of those which have the same ratio with them, then the extremes, that is A and D, are going to be relatively prime. So let's see how we can prove that A and D are relatively prime if A, B, C, D are 4 numbers which are in continued proportion and they are the least such numbers. Okay, so we are given A, B, C, D are the least in continued proportion. Since they are in continued proportion, it means A is to B is equal to B is to C is equal to C is to D. So the first thing we do is take E as the GCM of A and B, greatest common measure. That is our E. Now we find F such that E is to F is equal to A is to B, where E and F are the least numbers. So basically, we take the GCD of A and B and we find F such that E is to F is equal to A is to B. Okay. Then using E and F, we start building the continued proportion of 3 numbers, 4 numbers. How long do we keep go about doing this? Till we reach the number of numbers that we are given. So we are given 4 numbers, so we stop at 4 numbers. Okay. So we have seen this in the previous position, how to do that. Take G is equal to E square. Take H is equal to E times F. K is equal to F square. So now we have got this. These are 3 numbers in continued proportion. Now we take the next step of constructing continued proportion of 4 numbers. So what do? We take L as E cube, M is equal to E square times F, N is equal to E times F square, and O is equal to F cube. So basically what we have done, we have using E and F, we have constructed the continued proportion of 4 numbers. Basically the idea is that this should be equal to this. So if we can show that this is equal to this and L and O are relatively prime, that means because they are equal, we can say A and D are also relatively prime. That's basically the path. So let's take it forward. G is to K is equal to E is to F. How? Remember, 2 numbers are in proportion. Their powers will also be in proportion. G is equal to E square and K is equal to F square. So since E and F are in proportion, that means their squares are also in proportion. So we can say G is to K is equal to E is to F. And here if you remember, L and O are what? L is E cube, O is F cube. So again we can say L is to O is equal to E is to F. Since L is equal to E cube and O is equal to F cube. And since we used our previous proposition to build this, we know L, M, and O are the least where A, B, C, D is equal to L, M, N, O. That means basically A is equal to L, B is equal to M, C is equal to N, and D is equal to O. GCM of E and F is equal to 1. Because remember, E and F are the least numbers, yes, which form this proportion. So that means they are relatively prime. Now, since we have built G and K using E and F through powers, That means G and K are also relatively prime, and L and O are also relatively prime. Now, A is equal to L, B is equal to O, since we basically built LMNO using GCM of A and, which means GCM of A and D is equal to 1, or A and D are relatively prime. That is proposition number 3 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions and references to previous propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.